Okay, folks, today we're going to look at the cosine law. So last time we looked at something called the sine law, and we could use that to solve for things in those triangles that didn't necessarily have a right angle. Now, the way the sine law worked, if you've forgotten, you need to have corresponding angle and side pairs. So in a triangle, an angle and a side pair would have to be across from one another. So in this triangle, the angle of 31 and the side length of RQ, which again you can write as the lowercase letter p, excuse me, they're opposites from each other. So this would be one angle side pair. Now if I look around the rest of the triangle, I don't necessarily have enough information to have two side angle pairs. I only have one angle, so there's no way for me to get the red or the green ones. Even though I have two sides here, I can't use the Pythagorean theorem to get the third one since there isn't a 90-degree angle. So we need another way to deal with this. So we're going to talk about something called the cosine law. Now before we go ahead and actually use it, it's helpful to figure out how it even works. So we need to prove this. So given that you've got this triangle provided, triangle ABC, what we're going to do is we're going to use this information to kind of prove why this is going to work for us every time. Now, before we do that, we need to make a little change to this diagram. So in the middle, you've got a height, an altitude, H and A. But that A also appears on this side, so it's helpful. Let's just call this H. Okay, so we're going to take that A out. Now we're going to see two right angle triangles in here. And they don't really look like it, but we're going to add these in. Okay, they should have been there from before, but that's okay. So if I ever drop an altitude perpendicular to the base of that triangle, that's going to create that 90-degree for us. Okay, so now I have two right triangles. So we'll number them triangle 1 and triangle 2 just to help us clarify our proof here. So we're going to do things simultaneously in both triangles, and we're going to use the information to jump back and forth. So if you need to pause it, rewatch to see where I've gotten something, then by all means you have the ability to do so. So triangle 1, let's say something about that one first. Now if we're looking at this triangle, I've got a right angle, which means I can use the Pythagorean theorem. Now this bottom side where it says c minus x, now A to B is called side length C because A to B, or B to A, whatever you call it, is across from angle C. Okay, now we've basically split this into two parts. We've called this side x, so if I do C, which is the whole thing, and I subtract x, I'm going to get this length of C minus x. Okay, so we're going to do something with the Pythagorean theorem first in this first triangle. We're going to write it in terms of the hypotenuse. So A squared is going to equal to C minus x, that binomial squared, plus h squared. Okay, so the square of the two sides have to equal the square of your hypotenuse. That's the Pythagorean theorem. Okay, now we're going to jump to triangle 2, and we're going to do something over there as well. So in triangle 2, we're going to do the Pythagorean theorem here again. Yeah, again in terms of the hypotenuse. So b squared equals h squared plus x squared. Okay, and then we're going to jump back to triangle 1. Now, if you look, in that binomial, I've got an x, it's going to end up being squared, and I've got an h, it's also going to end up being squared. And I think you can see where we're going. The expression in blue also had an h squared and an x squared. So let's go multiply this set of brackets out, and then we'll do a little bit of a substitution. So a squared is going to equal to c squared minus 2cx plus x squared plus h squared. Okay, what you can see is that the expression we just got from that expansion is equal to our expression that we wrote in blue. So what we're going to do is we're going to take that expression and substitute it in. Okay, so this means that a squared is going to equal to c squared minus 2cx plus b squared now. Okay, now we're getting somewhere. Now if I can take that b squared, place it in here, it looks a little bit nicer. Okay, but I really want to have this in terms of the three sides of this triangle. I want to have it in terms of A, B, and C. Right now I've still got that x in there. Now remember, x was just part of that side length. We want to really have it in terms of the whole thing. So we need a way to come up with an expression for that x. Now we've already used the Pythagorean theorem. Okay, so that really isn't going to help us anymore. And what could help us is writing it in terms of one of the angles. Now, we're going to look at angle A in that second triangle. Okay. Now, if I can write an expression of A that uses x, I can probably substitute that into that expression as well, like we did with the Pythagorean Theorem expression. So let's say that if we do the cosine of angle A, that means I can take the adjacent side length to it, which is going to be x, divide that by the hypotenuse, which is going to be b, and I've got an expression now that has x in it with something new, okay, something I haven't used yet. Now, if I read it in terms of x, that means, therefore, x is equal to b cosine A. And now I've got something for x that I can also substitute in. So let's do just that. That means that a squared equals c squared minus 2c times our expression for x, so b cosine A plus b squared. And so now we've got another expression. Now we're going to write this, we're going to rearrange the terms, make it look a bit nicer. So a squared, actually let's see, so therefore a squared is going to be equal to b squared plus c squared minus 2bc. So originally I had 2 times c times this, so I'm just reversing the b and the c to keep them alphabetically in the same order. So 2bc then, cosine A. And this would be an expression that relates the 3 sides of that triangle, ABC, and an angle. Okay, so originally, let's pop back to the picture. That triangle was A, B, C. Okay, so we've written it in terms now of the 3 side lengths of that triangle and an angle. Okay, and we're going to talk about what this actually means when we go to solve this. So if I look again at that formula, a squared equals b squared plus c squared minus 2bc cosine A. If I look at this and notice a pattern, my a, the first term that's squared, so whatever it's equal to, that a, and the a that's with the cosine, that's a side angle pair. They're opposites to each other. One's the side length, that's the lowercase. One's the angle, that's the capital letter. If you notice, that's what we circled here also. Now, even if I turned the triangle or even tried to find a different angle, if I instead had this in terms of the side length b, and it said b squared instead, my angle on the end would be angle b. Likewise, for c, same thing would be true. So you can see underneath that your cosine law says in any triangle ABC, you have this law available to you. Now, if you want the other ones as well, so this would get you angle C, if that's what it was called. You could have it say a squared equals b squared plus c squared minus 2bc cos A, or you could say b squared equals a squared plus c squared minus 2ac cosine B. Again, the important part here is that your side and your angle, the one you're solving for, and the one attached to cosine, they're opposites. Okay, they need to be. Okay. Now, the way that this is written would allow you to find a side length. What happens if you needed to find an angle? Now, you could rearrange all of this and do some manipulating, which is totally fine. Or you can just use the formula that's already been manipulated. So cosine A equals b squared plus c squared minus a squared over 2bc. Now, again, the formulas you're given pretty much, so you could always build one and then do some work to it, manipulate it to get the other one. And again, this would work for all 3, so you could do cosine B equals or cosine C equals, whatever you needed to. But for this one, you're still going to notice that your angle that you're trying to find, capital letter, and the one you subtract are always going to be your matching side angle pair. So for a comparison, I'll give you cosine B also. So cosine B is going to be a squared plus c squared minus b squared over 2ac. And again, you'll see that your angle and your side that is across, or yeah, your opposite side angle pair, there's going to be the side that's being subtracted just like before. Okay, so there's the formulas that we can use. So now that we know that, we can use it to do a couple of things. So if we flip it over, we're given a triangle GHI, solve for the largest angle rounded to the nearest degree. Now, Side lengths in a triangle are dependent on the angle across from them. So a little trick you can do is kind of put your palms together. Now, your fingertips should be right close together. Now, if you make that angle between them larger, you're going to see your fingertips become further and further apart. So the bigger the angle, the bigger the side length across from that angle. So the angle I'm talking about is in between my palms. The side length is fingertip to fingertip. Now, the bigger you make that angle, the bigger the distance between your fingertips. So that side length and the angle, they are related. One gets bigger, so does the other one. Okay, so I know by looking at these three side lengths that the angle I need to find is angle H, because its opposite side length is the largest. Okay, so we're going to find angle H, and I only know three side lengths. So I can't use Pythagorean Theorem. It doesn't help me because I know all those sides, and I don't have a 90-degree angle. So we need to do something else. Now, I can't use the sine law like we learned last time, because I would need to have at least one angle to form a side angle pair. So my only choice now is cosine law. Now, if we write it in terms of this triangle, we're trying to find angle H. So the cosine of angle H equals the 2.8 is going to be side length G, 1.7 side length F, 3.1 side length H. They're always named for the angle across. Okay, which means that I need to do G squared plus F squared, and I'm going to minus the side length that's across from my angle, so H squared, and we're going to divide it by 2 multiplied with the first two sides I've placed in, so 2GF. Okay, so here's our formula. So essentially now all we're doing, plugging in some numbers and evaluating this expression. So cosine of angle H equals G squared, so 2.8 squared plus 1.7 squared minus 3.1 squared, divide it by 2, 2.8, and then F is 1.7. Now with all of these things, you can put them in your calculator all at once, provided you use the right amount of brackets. But you do need to be in degree mode as well. So please make sure that you put it into degree mode, and then we can go plug some stuff in. So we can do, actually, I won't use, that's fine. Let's do 2.8 squared plus 1.7 squared minus 3.1, and we'll square that as well. Enter. So I get 1.12 for the top, and we're going to divide it by everything on the bottom. So I'm going to put a first set of brackets, then we're going to put everything inside. So 1.7, and we'll close that bracket. So now it'll take my answer, divide it by the product of these three numbers. Okay, so I do get a weird decimal here, which is fine. Now just remember that that isn't my angle yet. Okay, that's actually equal to the cosine of my angle. So 0.11765, we'll say. Okay, as long as I take 4 or 5 decimals here, the rest are pretty much irrelevant. They don't really make a big difference. Okay, now I need to do the inverse of cosine, like we did for the sine law. So cosine inverse of my angle, or of my ratio, so 0.11765. And I get about 83 degrees. Now I was asked for the nearest whole number, nearest whole degree. That means that angle H equals 83 degrees. Okay, so there's the cosine law in action with the side lengths to find an angle. Now we could use that law again, the other version, to actually find side length. So if I look at the one underneath, I'm given a triangle ABC. They tell me there's some dimensions of it, but they don't give me a picture. Okay, we're asked to find side length A to the nearest tenth. So we got to draw a triangle first. That's helpful not to draw a right angle triangle, okay, because we don't know for certain that it is or isn't. So try your best to draw a triangle that isn't a right angle. Okay, you even have one for reference up here. I know it's kind of hard because we're so used to drawing them with right angles, but here it's better if you don't. Okay, we'll label it. So ABC, it's the triangle we've been told. Now we know that side B is 35. So I'm going to locate angle B. Side B is across from it. So that's going to be 35. Side C is 45. So find angle C. Opposite to it is side C. So 45 meters. And I'm also told that angle A is 36. So 36 degrees. Find side length A. Okay. There we go. So the side length is across from the angle. Now I have enough information to do this. And again, no Pythagorean theorem because I don't have a 90. No sine law because I only have one angle and I don't have the one of the other ones to form that other side angle pair. So cosine law is our only choice. Now, since we're finding a side length, we're going to write this not in terms of cosine of an angle, but in terms of the side length. So we want to locate side length A. Okay. Now it's kind of deceiving since the triangle is named ABC. So just be careful that you're writing it in terms of the correct thing. So where the formula is really a squared equals b squared plus c squared minus 2bc cosine A. You could have used any letters you want, x, y, z, p, q, r. It doesn't matter as long as you're remembering that you really need to make sure that it's the side angle pair that are opposite. Okay, sometimes your pictures are going to be different, like the one above was H, G, and F. And again, we just had to make sure that our angle and our side length that we were subtracting were opposites, okay? Everything else just gets filled in. So let's go fill this with our numbers. So a squared is what we need to have. B is up here, so 35 squared plus c squared, which is 45, minus 2b c cosine A. That should be degrees. Now all of this can actually be placed in your calculator all at once. So 35 squared plus 45 squared minus 2, 35, 45 cosine 36. Now I've placed it in exactly as it looks, all the brackets and everything. So when I hit enter, I get this large number 701. Now that doesn't make sense that this side length would be 701 comparing it to the other ones. So just remember that you've solved for a squared. Okay, 701.596, 4677. So in order to get a, please make sure that you square root both sides. So you can square root the entire answer by pressing second the negative button. That will give you your previous answer that was on your screen. Hit enter. 26.5, since we're going to the nearest tenth of a meter. So 26.5, and that's meters. Okay, so there's side length A. Now that I know that side length, I can use the sine law to find out another angle. Didn't have enough information before, but now I do. Okay, as soon as I've got that side length, I have enough information to make those side angle pairs. Okay, I only had to find the side length, so essentially we're done. Okay, the last one in here. Lorena lost her purse in the mall. She lost the summer between Safeway and the Bay. Distance from Safeway to the Bay is 450. So we're going to add some stuff in as we go. So Safeway to the Bay is 450. Okay, the distance from Lorena to Safeway is 620. Okay, and to the Bay is 740. Okay, so there's our scenario. What is the angle to the nearest degree from where she's standing? Okay, right there. That we're trying to find angle L. So that means if we label these sides with some letters so we can build our formula, that means the 450 is side length L, 740 side length S, 620 side length B. Okay, I just used the first letter of each of those places to do this. So that means that the cosine of angle L has to be equal to B squared plus S squared minus L squared over 2BS. Okay, so here's my scenario. Okay, that L, angle L, side length L, they are my opposite pair, so I'm subtracting the side length. The other two can get added in any order. You can put SB and then SB if you want, because addition and multiplication, the order doesn't matter. Okay, so we can plug in some stuff now. So that means the cosine of angle L equals 620 squared plus 740 squared minus 450 squared over 2BS. Okay, so the cosine of L equals, now we've got to put in some numbers, so 620 squared plus 740 squared minus 450 squared. Okay. Divide that by the entire expression on the bottom, so just remember that first set of brackets if you're going to do this all at once. 2 times 620 times 740. Close that bracket, enter. There's my ratio. So 0.79500. Now one more step, make sure you do that inverse. So angle L equals, make sure you do inverse cosine. Sometimes that happens, you just hit the wrong one. About 37 degrees. We are asked for the nearest whole degree, so 37 degrees is the angle in question. There we go. There's cosine law. So you can use this to find not only an angle, you can also use this to find a side length, depending on the information you're given. So if you're wondering about a way that when to use which ratio, things like that, what you could try and think about is if you were given a scenario like this, where this is right back at the beginning. So if I take these out and you look at this, really I was given these two side lengths I kind of outlined in purple. Okay, so think about your hands back together. You know how long your hands are, right? So I know those two. If I know the angle in between them, you could call this, if you need a way to remember this scenario, a side angle sandwich. So your sides are your bread, the angle is all of the stuff inside, your meat, cheese, pickles, lettuce, tomatoes, whatever. If you have a side angle sandwich, that's going to be a cosine scenario problem. So that's going to be a side, an angle, and another side. So if you think about this, okay, there's your side angle side. This is where you would need to use the cosine law. Now, it could be any other angle, doesn't matter. The other scenario which you would need to use cosine law is if you knew all three sides and no angles. Okay, if you didn't know an angle, you couldn't use the sine law because that one's built on angles. You can't use any Pythagorean theorems because you know all the sides. If you only knew the side lengths, cosine law would be your only choice because you couldn't use for any right angle trigonometry. You didn't have a 90. So you'd have to use the form of the version of the formula, essentially, that solves for one of those angles because you can fill in all the side lengths. Okay, so there's a little bit of a trick to see which one you can use and when. Okay, so I hope that helps. And that's essentially the end of our trig unit for Math 20-1. So again, if you do have some questions, let me know, let your teachers know, and we can help you out. Okay, so we'll see you in the next one.